All right, these are some examples on calculating average atomic mass. So naturally occurring europium consists of two isotopes. Um, the isotopes mass being 151 AMUs and 153 AMUs. Those are the two naturally occurring isotopes. Europium 151 has an abundance of 48.03%, and europium 153 has an abundance of 51.97%. What is the average atomic mass of europium? So what this means is that of all of the europium in the world, or in nature, 48.03 of it is 151, and 51.97 of it is 153. So what we'll do is we take our percentages and we divide by 100 or move the decimal over to the left two places, whatever is easy for you to remember. Okay, and we're going to multiply it by the mass of that specific isotope. Okay, so you're going to have the abundance decimal times the isotope mass. Okay, so let's go ahead and do this real quick. The abundance decimal, so let's go and take a look at 151, is going to be, so 48.03 would be 0.4803, and I'm going to multiply that by the isotope mass for that abundance was 151, and then I'm going to do the other one as well, 0.5197, and I multiply that by 153, and I'm going to go ahead and get these products. These products being 75.53 and 79.51. So those are the two products. I'm then going to add those two products together to get 155.04, the unit being AMUs. This, okay, is our average atomic mass of europium, is 155.04. Okay, you would not, repeat, do not just take 151 plus 153, end up with 304, and divide by 2 to get your mass. Okay, it's a weighted mass, meaning you have to pay attention to the percentages. It's not a 50-50 shot, meaning half of it is europium 151 and half of it's europium 153. Okay, if it was the case, then you could do this. Okay, but you can't, so don't do that. All right, let's go ahead and take a look at another example. Strontium consists of 4 isotopes. So now we don't have just 2, we have 4 of them. And those isotope masses of 84 with an abundance of 0.50%, 86 with an abundance of 9.9%, 87 with an abundance of 7%, and a mass of 88 with an abundance of 82.6%. Now, one way you can kind of judge, it's not 100% accurate all the time, but it's a good way to kind of feel your way through a problem. If you look at the abundance, a majority of the isotopes in nature are strontium-88. Okay, 82.6% of it, which means you're probably going to have an average near 88. Okay, well, maybe a little less, maybe a little more, but it's a kind of good way to judge it. Okay, especially when you have one that has such a large abundance compared to the other ones, which don't even reach 10%. Okay, so let's go ahead and write out what we have. We have 4 different isotopes now. We have strontium-84. Okay, we have strontium-86. We have strontium-87. And we have strontium-88. So, doing the 4 problems, okay, I'm going to take 84, and I'm going to multiply it by that percentage as a decimal, so that'd be 0.0050. 86, that isotope mass, times its abundance, which would be 0.099. The next abundance would be for 87, meaning strontium 87, and that abundance is 0.070%, or 0.70 as a decimal. And then we actually have 88, which has an abundance of 0.826. So I'm going to go ahead and do the math real quick. So the first abundance is going to be 0, or the product is going to be 0.42. The next one's going to be 8.51. Okay, I multiply them together. So 87 times 0.070 is going to be 6.09. And then lastly is 88 times 0.826. That should be 72.69. As you notice, I'm not paying attention to sig figs right here. All I'm doing is rounding to the hundredths place. Okay? I'm going to add all these together. Right? So I take all these products, I add them all together, and I'm going to end up with 87.71 AMUs. Now, if you remember at the beginning of the problem, I said because so much of the abundance of this element is having a mass of 88 AMUs, well, 87.71 AMUs, that's pretty close to strontium 88. So it makes sense, since so much of it is 88, that the mass, the average should be near 88. All right? So those are a couple example problems. You're going to have a lot more on Monday and Tuesday. In fact, we're going to play with these types of problems a little more to introduce some more critical thinking and some different aspects of algebra. All right?